Today I'm gonna teach you how to find the angular velocity. And the question asks you, they ask you with 4 bullet points, and they give you the angular position and the diameter. So for question A, find angular position, right? So I'm gonna denote angular position by theta in radian and in degree at t1 equal to 2 seconds and t2 equal to 5 seconds. Sorry. So I'm gonna denote theta 1 for t1. So they give us the angular position 2 radian per second cube multiplied by t cube, right? So theta 1 means you have to substitute t1 value in. So 2 radian second cube multiplied by 2 second power 3. So the answer is 16 radian per second. And this is in radian. Now I'm gonna find it in degree. So I'm gonna take 16 radian per second multiplied by 360 degree 2 pi radian. Okay, so it's gonna be 920 degree. So this is angular position 1. Now I'm gonna find the angular position 2, denoted by theta 2. 2 radian per second cube multiplied by t cube. So we substitute t2 in. 2 radian per second cube multiplied by 5 power 3. What's the answer of this? Answer is 250 radian. I'm sorry, the first one we do not have radian per second. We only have radian. My bad. Because we cancel second and second. So they ask the same. I will convert from radian to degree. Radian multiplied by 360 2 pi radian. So this one equal to 14000 degree. So I finished question A. Gonna continue to question B. Question B, they said find the distance that a particle on the flywheel rim moves over the time interval. Okay, don't forget here, I know it here, time interval from t1 equal to 2 seconds, t2 equal to 5 seconds. So B, during the interval from t1 to t2, the flywheel angular displacement is denoted by this theta 2 minus theta 1. Yeah, and we have theta 2 value. Theta 2 is equal to theta equal to 250 radian minus theta 1 is 16 radian. We found it above this question. So the displacement of theta 2 and theta 1 equal to 234 radian. Okay, now we found the displacement of the angular position. So this is the radius is half of the diameter. So R equal to D divided by 2 equal to, the question asks D is 0.36, the 0.36 meter, don't forget the unit, divided by 2. So R is equal to 0.18 meter. The angle must be expressed in radian, right? And we had the formula of displacement here. This is S equal to R theta 2 minus R theta 1, and we're gonna take R out, theta 2 minus theta 1. So R multiplied with the displacement of angular position. Oh, sorry, not really two. So we knew all the value. So this one is 0.18 meter multiply 234 radian. This one is equal to 42 meter. S. This is the answer of question B. So question C. Question C, what did they ask? It said find the average angular velocity in radian per second and revolution per minute. So this is simple. We're gonna use the formula of the angular velocity. Omega AV Z equal to theta 2 minus theta 1 over T2 minus T1. Okay, so we substitute the value in. This is 250 radian minus 16 radian over T2. This said T2 is 5 second minus 2 second. So the first question is gonna be in radian per second. This is 78 rad per second. Okay, we got one. So I'm gonna convert this into revolution per minute. How? I'm gonna take 78 radian per second multiply by 1 revolution over 2 pi radian. Okay, and multiply again because I want to find it in second, not minute, not second. So 1 minute equal to 60 seconds. So I got this. My answer is 740 revolution per minute. This is the answer for question C. So this is the last question that they're gonna ask. Is it find the instantaneous angular velocity? Instantaneous angular velocity, we're gonna use the formula again. Put it here, D. The formula is omega z. We're gonna use calculus in this. dt. Right? We know the value of theta, so we're gonna substitute in d dt. Theta is 2 rad second cube multiplied by t cube. Okay, so we're gonna do the normal differentiate. So my differentiate is equal to 6 radian per second cube multiplied by t square. And they said the interval is interval t1 2 second and t2 5 second. I'm gonna put omega 1z for T1. So 6 radian per second cube multiplied by 2 second square. Because we substitute T1 value in, this become 24 radian per second. So omega 2, 6 radian per second cube multiplied by 5 second whole square equal to 150 radian per second. This is our answer. So if you don't understand, you can leave the comment below, and don't forget to give me a thumbs up if you like this video. Thank you.